separate occasions at the same time. So that's impressive. In Australia, we do not have MSSL numbers or EBS numbers. We have NIMIs. And in our current design, there's no real correct place to put the NIMI. We've been putting it in as account number MSSL thus far, but if we have a column named account number MSSL, someone in the future might, pose some kind of restriction on what could be in there, some kind of constraint, which would be valid for MSSL, not for NIMI. Like, this is asking for trouble in the future. So for Australia, we would like to have a place where we can store the NIMI that is not named account number MSSL. But for solar, there's a even bigger issue, which is that the solar non-retail customers, we deal with them directly. So there is no third party to issue an account number. Need to wait following. What we do is we have a number in the connection table, which we issue. Because it's a number that we issue, it is unique by definition. We have full control over this number, so we can ensure that it is unique. And as you can see, it's also not nullable. This means that we issue this number for every connection. And then we have a table which stores the account numbers. So this references the connection ID, and then we have a number and a type. So in case of Singapore, type could be MSSL, and then you would have your MSSL number in here. But also, if you have an EBS number, the type would be EBS, etc. But if you're in Australia, the type would be NIMI, and this would be the actual NIMI. And for the solar non-retail customers, there would be no records in this table, and rather we would just depend on this number right here. So again, this number we can always rely on because it's not nullable, it is unique, we have full control over this. But in communication, we can decide which number to use. So in Singapore, we'll probably use MSSL number if available, and otherwise EBS. But for the non-retail customer, we can have an index on connection ID, which means that looking up the MSSL number or the NIMI for a connection is going to be extremely efficient. And we can also have a unique index on the combination of the number and the type, which means
don't like password rotations because they make you more vulnerable. Always. The reason why is once I find out whatever your company's standard password is, every company has a standard password, at least most of them do. They'll have some kind of a logic to it, or they'll have maybe the company name and it'll be like company one. And they say you gotta go change your password before it goes through. This happens quite a lot. A lot of companies do this shit. It's really stupid. Now, what happens when you do a password rotation? All I have to do as an outsider is find out how long your employee has been at the company, how much time they've been there, and what your password rotation requirements are. Let's say it's every 3 months. Now I find out how long they've been there, and let's say that they've been there for 12 months. This is now company 5. This is what human beings do with your password rotations. That's how it works. It happens every single time, and every time I'm on a pen test, I break into thousands of accounts by doing this. I don't like password rotations because they make you more vulnerable. Always. The reason why is once I find out whatever your company's standard password is, every company has a standard password, at least most.
Is that finding a connection by MSSL number or a NIMI will also be extremely efficient. So this does not have any significant performance hit. The addition of a second table can largely be abstracted away from the rest of the code base. Through our service layer, we could have like our connection service make sure that it kind of deals with this internal added complexity of the extra table. So so whenever we yes, let us know what you think. The three of us, the gang of three, we think that this design is neat and it's scalable, and whether there could be this number, whether there could be that number.
here. As you can see, we have
What do you think is worse? Testing your services with in memory databases, the ones you would never use in production, or testing services using mock data, the one which could come from a file or from a mocking framework? In both the cases, who would test your assumptions? And what if the implementation details change for the data that you use in production? How would you ensure that your mock data is correct? And if you think neither of this is a good choice, let me add another option to you. What if you could test your services locally with a real database, which ease. If the last option sounds exciting, this session is for you. Hi everyone, thanks for joining in. I'm your host, Mala Gupta. And today on IntelliJ Idea Live Webinar, I'm excited to host Marco Beller, my colleague from JetBrains. And in this hands-on session, Marco will demonstrate how to test your code with database using test containers locally. Welcome, Marco. It's a pleasure to host your session today.
Hi, Mala, and it's very great to see you. So, test containers. Hopefully, we're going to manage to answer all the questions you just posed. And we're gonna talk about. We're basically gonna take everyone who's watching from being a test containers zero to hopefully a hero. And the way you might know me is that I don't like theoretical talks and giving you kind of a reference talk about here's the A to Z features of test containers. Instead, we're going to keep it practical and a bit fun. Essentially, what I want to do is I want to have a little role play, imagining it's my first day at work at a new company. And I have a colleague I want to bring up to speed with my project and see how test containers fit into the whole project lifecycle, essentially. And so that you can take everything you see here in this session away and really apply it in your day-to-day work. And that is also why we have a special guest today.
Hello.
Hi, Trisha.
Hello, Trisha.
Hello.
Right.
And I think I would have lots of fun seeing both of you asking questions and answering questions. So I can relax and just see you both talking with each other.
Yes. So Trisha is hopefully going to hammer me with questions about test containers or the stuff I'm doing right or wrong. We'll see about that. But essentially, I'd just say, Trisha, should we basically jump right into test containers and then see what's going to happen?
Yes, absolutely.
And, I'm sorry to interrupt, but before I let both of you take the stage, let me share some quick housekeeping details. Everyone who's watching, please use the YouTube chat to post your questions. We all would answer the questions as you post them. And the session is being recorded and it would be hosted to IntelliJ Idea's YouTube channel. So if you haven't already subscribed to our channel, please do that now. And last but not the least, of course, if you like today's session, please do not miss to like the video. Marco and Trisha, I'll let you take the stage now.
Thanks, Mala.
Thank you, Mala. All right, cool. So let us start with the boring stuff. Trisha, the first day at work at a new company. And what we do need for that is a project. And actually, I created a tiny project on GitHub that you, the watcher, can clone, and then you can repeat everything I'm doing. You can essentially repeat on your own machine. And it's in the Marco Bieler JetBrains repository. It's called Test Containers Demo, where you'll find it. Just search for my name. You'll find it. Clone it onto your machine, and you're essentially good to go. It's a Java Spring Boot project. It doesn't really matter for test containers, but that is the technologies I chose for this talk.
Yeah, I was going to ask you about that. I can see the Maven wrapper, and I was thinking, how did you create this? But it's a Spring Boot project.
It's basically just a Spring Boot project created with the Spring Boot initializer. It has a Docker Compose file inside because we're going to talk a bit about it as well. But then it's just a REST controller, and we're going to see it in action hopefully soon. Right, and then what you also need, test containers, is essentially, and we're going to learn what that means, a wrap around an API around Docker, which means you need to have Docker installed on your machine, which means you need to have a couple of things installed on your machine. First of all, Windows subsystem for Linux. If you're on Windows, it's different on macOS and different on Linux, but I'm going to show you the Windows steps here, so you'll have to make sure to get WSL2 installed on your machine.
I really wish I'd had you with me about 2 weeks ago. I went through all of this 2 weeks ago, and I couldn't get it to work properly. So now I'm going to watch you really carefully and see what you do.
Yeah. Yes, yeah. And the issue is, and I can tell you, it's something I wanted to talk about in a bit, but just to take it away, it could be that you're working inside a company, especially bigger companies, where you cannot install Windows subsystem for Linux, the Windows subsystem, because you need to have some. You need to enable the subsystem. You have to have some kernel files, updates, enable a virtual machine feature, whatever. If that's the case, you have to do it on a private machine. You won't be able to do it on your work machine.
I can tell you exactly what my problem was. I did not read the instructions. I just clicked next, 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 and then it didn't work properly.
Right, yeah, yes. And you have to go through all of these steps, essentially, to make it work. Then go to the Docker homepage. I never know where to click, but no, get Docker Desktop again on Windows. You just download the latest Docker download for Windows. And make sure you have the latest one. I had some weird issues with older versions. I always kind of keep it up to date. So just make sure you get that. Then you have WSL2. You have Docker installed, which is already most of what you need. And last but not least, you need test containers. Let me just...
Can I interject a little bit?
Yeah.
I did find, because I have a Windows machine and a MacBook, and I did find, so you said that you don't have to do the WSL2 thing for Mac. I just wanted to go one step further and say it really is next on the Mac. The Mac it just works when you're installing Docker.
Right. And just to basically... Before we go to that homepage, let me just quickly show you. I have the project checked out on my machine. So as I mentioned, for people who know a Spring Boot project, it's a plain Spring Boot project. It has a main method, a test containers, demo application, Java class with a main method. And now it's my first day at work, or Trisha's first day at work. And what happens is you essentially check out your project, and you might be tempted to just try and run it, which I'm going to do here. So my application boots up, and I get a nice little error message in the log file here at the end saying the MySQL connector, which is the JDBC driver, tries to connect to a database, and the connection is refused. So my application doesn't start up.
I actually find this weird about Spring Boot applications, that even if you haven't told it to do anything with the database, some of them, depending on your configuration, the app just won't start if the database isn't there.
Yes. In my case, actually, there is a properties file, which you'll... Whoops. That was too fast. There's a properties file, an application properties file you find inside, and you'll find a couple of properties referencing a localhost database / some database, root, let's go Marco with the password, which kind of prompts Spring Boot to try to connect to such a database on startup. And now the thing is, well, what is the quick fix on your first day at work? And again, it depends a bit on your company. It could be the simple solution is, well, install a database locally. So you would basically grab a MySQL, in this case, the MySQL installation, install it locally on your machine. That's what I have.
This is what I've always done. So actually, I used to do this a lot at JetBrains. So I'm having to demo a bunch of stuff, and I have like a MySQL local and a Postgres local and a MongoDB local, and then you basically have to throw your laptop away and rebuild the whole thing later on because you don't know what's there.
That's exactly it, because it kind of, these databases kind of get, they don't rot, but there's kind of a maintenance burden with that approach. Basically, you install your database, then you kind of leave it running around. You don't know what version it is, what data is there, what database is there, all that kind of stuff. But still, it is a valid approach, which I've seen companies do because they, for example, don't allow you to install Docker and whatnot, which would be the second solution. Second solution, as I mentioned, Docker would be, you have your machine, you have Docker installed, and Docker makes it rather simple to just, pull down your Postgres image and boot up a Docker container and then just throw it away again.
Wait. You just said a bunch of words that if I don't really understand Docker very well, I don't understand. So
right.
you said pull down a container and boot up an image.
Yes.
And then throw things away.
Yes.
And I don't really know what that means.
All right, yeah. So essentially what you have is, you have to imagine that, for example, there's Docker Hub, a huge repository of Docker images. A Docker image could be it's interesting to get into what a Docker image exactly is, but just imagine you have some sort of a virtual Postgres database, or you have a MySQL database. That's a Docker image. So you could have a MySQL Docker image, you could have a RabbitMQ Docker image, you could have a Kafka Docker image. Basically, for these technologies, you have a tiny Docker image, and when you start the Docker image, it turns into a container. Oh man, that is a very simple explanation, meaning your database will run, and you can connect to it on your local machine, so to say. And then when you stop the Docker container again, your database will be gone, and you can just delete it from your machine. Did that make sense? Kind of.
Yeah, it's about like disposable installations.
Yeah, disposable installations. That's a good way to put it. Disposable installations, right? And especially for MySQL, for example, MySQL has a Windows installer, and that kind of works. If you try to get an Oracle database running on Windows, it's a completely different topic. So Docker makes some things nice, because you have, for all these databases, for example, you have ready-made official images. You can just pull them down, and you have a database up and running in, let's say, 10 to 15 to 20 seconds, essentially. And I'm going to show you what that looks like in a second. Right, which means, still talking about it, Docker. And please, Trisha, don't ask me what Docker Compose is now.
I'm not going to. No, Docker Compose I'm kind of fine with, because as someone pointed out in the comments, if you open it, it has a little green button, a little green run button on the side, and I'm fine with that. I get that.
Right, yes. And so what happens is, in companies, basically, to solve that issue with starting the application, you might have a Docker Compose file in your project directory, where you can essentially say, my Docker Compose file, what I want to do is I want to have a so-called service. It's called DB in this case. And what is that service? Essentially is pull me down the latest MySQL image from Docker Hub in this case. Set a couple of environment variables so that the database that boots up is called some database, which conveniently matches the database name in my properties file with the password, which is set in my properties file. And then please bind the port 3306 from the container to my host, which is a Docker-specific way of saying, let me just be able to connect to my database through port 3306.
I'm not going to poke you too much on that, because I know Dahlia's about to do a video on that. So
right, okay.
That could be covered later.
So let's actually do that. Let's click that button, that run button up here, and I can see that basically my database is now booting up. It's going to take a second, so there's some log messages here in IntelliJ IDEA, and what I'm just going to do is I'm going to go to localhost 80. Did I boot up my Spring Boot my Spring Boot application? I did not, I think.
No, it's because it didn't run the first time you ran it.
Right. Thank you. So I'm just going to start that again.
And then it should connect to your database this time.
It should now connect to my database this time. Let me just look at my browser again. Localhost 8080. Right. And I can see localhost 8080, I basically get a JSON object back, which says there's first name Tricia, G, and
G.
Marco. G, sorry about
It's
that.
all right. It's
G.
fine.
And Marco Vila. Right. Right. Okay. So that works. Now we solved the problem of local development for now. The question is, what happens now when I start running tests? Essentially, now I have my Docker Compose database up, which is all nice and good. So instead of having it installed on my machine, I now have a Docker Compose database up. But again, let me actually just stop my Docker Compose container. My database is now gone again. So that is how quickly you basically boot up a database and get rid of it again. And I have some integration tests. And when I run these integration tests now, I mean, again, they won't work because they're going to try to connect it to the same database, right? So you just get a huge stack trace. Essentially, somewhere at the bottom, it's going to say the same thing, connection refused.
So my naive assumption at this point, and I have literally done this, is I'm like, well, look, I have a Docker Compose file, so I'm just going to use that to start up the database and then run my tests against the Docker images which are running. Now, it's not very reproducible in other environments, but it does work.
It does. Yeah, so it kind of does work. It does work for you locally and has all the problems essentially that you might expect with an install database. So for the maintenance problems we mentioned earlier, the question is what kind of data is in your database? Does the test data pollute your local database? Do you have many different teams maybe working on schema changes? And is your database always up to date with these schema changes? And wouldn't it be kind of nice to have, as you just mentioned, some sort of a reproducible way that your tests have an empty, clean, always up-to-date database only for your tests. You don't have to worry about a Docker Compose file, but somehow magically a database boots up for your tests. And then after your tests have finished, the tests are gone again. That is the dream, basically. To spoil it, with test containers, that dream is essentially possible. So let me get back to what we need to do with some more boring stuff, because at the beginning, we just need a couple of dependencies added to our project. It's a Maven project in this case, POM XML file, Spring Boot, and we somehow need to get the test containers stuff inside to get started with test containers. And I'll just quickly go back to the homepage, test containers, and if it's the first time you're working with test containers, before I go straight to the dependencies, you might be tempted to click on the Quick Start button. When you click Quick Start, you'll see there's a JUnit 4 Quick Start, a JUnit 5 Quick Start, and a Spock Quick Start. And that's because test containers is somewhat integrated tightly with different test frameworks. So you'll have different dependencies and different even like annotations and whatnot, depending on if you use JUnit 4, JUnit 5, or Spock. And we're going to go with JUnit 5 in my case, because it's been out for 4 years or 5 years now, and it's.
And we should be using JUnit 5 now.
we should be using JUnit 5.
And you can use them together. You can use 5 and 4 at the same time.
Yes. And you can also use test containers manually, the manual API, which I'm also going to show in a bit. But essentially, choose your testing framework, your flavor, scroll down to the dependencies. And then in a Spring Boot context, Spring Boot will basically give me all these JUnit dependencies for free already. So I don't have to add JUnit Jupyter. I don't have to add these dependencies to my project. But what I would want to do is essentially add the 2 test containers dependencies to my project. So I'm just going to copy them, test containers, and the JUnit 5 bridge, so to speak. I'm just going to add that to my project. And I have to learn how to open up my IDE without, losing context. So I'm just going to paste that in here, refresh my project.
Command-Shift-I.
Command-Shift-I. Yes. All right. Then what we have up next, let me just see. You'll find a module section here on the test containers homepage. And on the left, you'll see you have different database modules. So you have my favorite name, CockroachDB, DB2, ClickHouse, MariaDB, MySQL, Oracle, whatever. You have a ton of different modules, test container modules. You even have modules for Kafka, for Nginx, for whatever, RabbitMQ, for WebDriver, for Selenium tests. So depending on what you want to do, you need to pick the appropriate module. In our case, for now, we want to simply start a MySQL database. So I'll go to the MySQL module and again, just fetch the dependency and copy that into my project. And also what I'm going to do is I'm going to show you maybe in a bit of time, let me also add the RabbitMQ module just to boot up a RabbitMQ message broker in a bit. Right. So that was the boring stuff, and I still hope you're with me. I'm just going to check if in my external library section, org test containers, it looks like there's the MySQL module, there's the RabbitMQ module, and now it's time to kind of learn what these modules are actually for. Right. Let's open up the integration test, and well, our goal is we want a MySQL database. For now, we want a MySQL database whenever someone runs the custom integration test. Which means you want to write private MySQL container equals new MySQL container. That is test containers API for give me a new MySQL container. There's a couple of things about this now. First, you can see that the constructor I'm calling is deprecated. That's because what they wanted to do is put in a Docker image name. Docker image name, and that refers back to what Tricia said at the beginning, is when you go onto Docker Hub, for example, and you search for MySQL in my case, you'll find the official MySQL image. And when you scroll down, you will see there's specific versions of that image. So there's the 8.026 version, 8.0 version, 8, latest, 5.7, 5.6. There's a ton of different versions or tags in Docker speak. And what you need to do is you need to decide, well, I want the MySQL image for version, let's say 8, for example, or a specific 8 version if you want to. It doesn't really matter, whatever suits you. So you're just going to go back and put in MySQL version 8. Here, for example, or 8.026, or latest, whatever you want.
My assumption is that you probably want to tie this to whatever you're running in production.
Yes, you want to tie this to whatever you're running in production, in your staging environment, in your whatever production environment. Make sure that you have the same database version. So in my case, now 8.026, across all your environments, essentially. Right. Then this line here, it doesn't really start a Docker container whenever it doesn't start your database, your MySQL database, whenever you run your test. You need to basically invoke the test container JUnit integration, which you do by using the add test containers annotation on your class. And then test containers will only start and stop containers which are also annotated with the add container annotation. Right. So now what's going to happen is test containers will have a look when your test starts. Which containers do I have inside my test annotated? And if it finds such containers, it will start them and it will stop them. And it will do that every single test method, which is not what we want. Because what's going to happen now is, let me just explain that again. If you have it like this, what's going to happen is, this test method gets executed, and before the test method, I get a new database. After the test method, database is gone. The next test method is executed, I get a new database. After the test method, the database is gone. So now we went from having just one, whatever, monolithic unmaintainable database installed on your machine to having a new database for every test method, which is essentially the other extreme, kind of.
There's definitely a balance there, isn't there? Because especially with database testing, it's always a bit of a question of like, am I supposed to be trying to trash it at the start and end of every test, so I know my starting state and my end state? And also, if you're running a lot of tests in parallel, then you don't always want to be using the same database. But on the other hand, like you said, the cost of starting up and tearing down is non-zero.
Yes. It's an interesting balance to have, especially with parallel tests is yet another, let's say, interesting topic, especially on CI pipelines, how you split up these tests. But for now, we'll see that in a second. What we're trying to do is at least get one database per test class and then one database per test run. So for example, that you have always a fresh database for all of your integration tests for now, assuming they're not parallelized. Hopefully that was a word. And we're gonna work towards that goal basically, and find the right balance. And to get that first step going, so just to have one database for this one test class, there's a simple fix. You just make the container static. So you will just have one MySQL container for the custom integration test class. It will be started before you run all the tests in this class, and it will be shut down afterwards.
But then you do need to be careful of if those tests are going to trample all over each other's data, right?
Yes, you have to be careful in that case. Yeah, as always. Yeah, then as not as always, but as normal, basically, then you have to be careful that the tests don't, trample over each other. Right. And just to kind of finish off with that, the thing is, if you're new to test the application, and that is my first with the username root. Let me just put that in, right? And with the password Marco. Something like that. Let me actually just quickly boot up the application. And that is my first side note, by the way. I have quite a beefy machine here, which I'm demonstrating this on. And you'll see that actually it takes some time to start a container, a MySQL database from scratch. So you'll see there's some endless log messages here, which is actually test containers waiting for the MySQL container to start up. So the MySQL database is ready. And it took me about, I don't know, 10 seconds or whatever that was, something like that. So let me just scroll down and see what happened here, because the test is still red. I still get a connection refused. Now, why is that?
I like the way it said connection refused, no further information available.
Yeah,
great, thanks for that.
Connection refused. So when you have a look at the log, what you'll see here, let me just see if I can go scroll to the right a bit. As I just mentioned, test containers will start your Docker container, your database, and then it polls the database every 100 milliseconds or so to find out if the database has started up. And you can see that it tries to connect to localhost, and then the port number is 49155. Some database is correct, but the port number is wrong. And the password Marco, right, that looked fine, and the user is root. So that is all fine, but the port number is off. And when I have a look here and say that there is no with port, essentially, there is a with expose port, which is something else, but I cannot set the port number. And that is one of the concepts in test containers. The port numbers are generated randomly. Why? Because if you want to start up a container for your tests, what does it matter what port your database runs on? What happens if the port is already used by another project? And that's why test container will boot up your database and give it a random new port, basically, on every test run. Which is a bummer for us.
So that does leads to the next question. Okay, how do I know what port I'm supposed to connect on?
Yes. So the thing is, what you can do is you can ask your test container, you can ask your MySQL container, hey, what is the port basically I need to connect on? Which also means the roles are kind of reversed, because now you need to boot up your MySQL container, and then you need to tell Spring Boot, hey, the URL in your properties file you try to connect to, that's the wrong URL. Please use a different URL, at least with a different port number. Which brings us to the topic, how do you tell? And that is, unfortunately, is a specific, it's specific to the framework you're using. So in Spring Boot, for example, there's a property, it's called, there's an annotation called dynamic property source, where you can override the properties in your application properties file for your test runs. So override props. And then you need a dynamic property registry, hopefully. Let's see if I have that right. And something like this. And then you say Spring data source URL. Well, the URL should not be the one in my properties file, but rather it should come from my MySQL container.
Oh, and that's cute. I like that.
And because that registry add call wants a supplier function, you actually don't call container.getJDBC URL here at that point already, but rather you give it a method reference, so it can be called anytime later on. And that way you basically tell Spring Boot, hey, use the URL that you get from test containers.
So you let test containers basically control all of that and then tell Spring where it is.
Yes, exactly. So what we're going to do is again, I just started the test. Again, we have to wait for, I don't know, 10 or 15 seconds to see if hopefully now my test is green and everything, I don't know, Spring Boot was able to, yeah, let's see. Looks better. It was red. Let's see what happened now. I didn't expect that, to be honest. Access denied.
Oh, your password's wrong.
My password's wrong. Let's see. What was the password? Let's go, Marco. Oh, sorry. Right. So
People in the comments were sort of saying the password's wrong. The password's wrong.
you can already see that is actually the issue. Now what I'm trying to do is I'm trying to boot up my test containers thingy and set the right username and the right password and the right database name to match whatever. And again, the thing is, for tests, all of this shouldn't, basically be an issue. What does it matter? What's the database name? What's the username? What's the password? And we're going to have a look at that in a second. But now let's hope this works. Trying to create, and you can see 10 seconds again, right?
Yay!
Success, everything worked as expected. Okay, cool. Now, that worked. And as I just mentioned, the thing is, let's forget about the password. Let's forget about the username. Let's forget about the database name. And let test containers
There is a very common separation in development teams that's understandable. It may even seem obvious, but in practice I think it's problematic. That is the division between user interface and back end, and specifically the use of user interface design as a way to specify desirable features of a system. In my experience, this is probably the most common approach to dividing up work, but it's also a very big mistake. So what is the problem with dividing up work like this, and how could we do better? That's our topic for today. Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. One of the commonest ways of dividing up work, I think that this is a fairly significant organisational structure mistake, and one that results in poorer communications, a lot of context throughout the development process, and fosters a more
Okay.
Transactional style of working and limits innovation and creativity as a result, as well as producing ultimately lower quality solutions, including worse user interfaces. I once worked as a member of a team that was handed UI designs from the UI team. These were presented as static pictures of user interfaces generated with some graphics program that I've now long forgotten the name of. The designs were often impossible to reproduce within the limits of the UI technology of the day, yet we were criticised anyway for not precisely reproducing the pictures in UI form. This was a while ago, and the technology was more limited then, but I still think it points to a deeper truth that's still true today. A user interface sketch, however accurately produced, is not the same thing as a real user interface. There's a translation going on here. A real user interface is by definition a much more interactive system, and real user experience is a lot more about the mental model that the user holds of the system than it is about the pixels that we paint on the screen. This mental model is deeply informed by the whole system, not just by the pixels on the UI. UI experts have known this for a very long time and talk about the
the payment order. Then, when the receive
Before starting, I will verify the transaction, whether the card is valid or not, whether it belongs to the correct.
I'm sure you've seen someone pay for something on the app in a secure and encrypted con, then the physical credit card can be
Hey guys, today we're going to design a payment. I think this is the most popular way to do orchestration is AWS step functions.
Hello everyone, welcome to my YouTube channel. In one of my previous video, which you can find the link here, I designed shopping carts, purchase, and that the account is in good standing. PCI compliance security.
Hi everyone, in today's video we are going to Hi everyone, welcome to my channel, and in today's ends, for example, if I service and some users would be seeking the status of their users would be pick, right? One TPS is very normal. Indexes and partitions and distributed storage, right? So the database scale is very high. Sorry, very low. So if it had storage requirements for that database, now the last thing left, payments, record the booking information, and then finally only one of them was able to book that.